Hi folks, today I'm making a video to correct a gargantuan mistake or several mistakes I made in placing the protection module in this Adcom amplifier. I went with a couple of assumptions that both proved to be wildly incorrect, and I will talk about those. But first, what I want to say is I get a lot of comments on my channel, and I try to read and reply to all of them. Some folks are just thanking me for the channel or the content, and I like to welcome those aboard. Other folks have questions which I may or may not know the answer to, which will necessitate me going out to the web or reaching for a book and either learning something I never knew or trying to remember something I never learned. But that's a good thing, because that way we both learn something. And then the third one is people pointing out errors I've made and omissions, and those are always gratefully accepted, because the whole purpose of this channel is to disseminate knowledge, and I don't want any mistakes out there, and any oversights I've made I want to correct, and I thank those people for posting them. And now this one, the most grievous error I made, was pointed out to me in a question from a poster who has no content on his channel, but is named Roro Seppel. I'm putting that on the screen now in case I'm pronouncing it wrong. And he asked me about DC sensing, since I didn't have a ground on this module. Now, what I had assumed incorrectly is that if you look at the bottom of this module, it's common to see boards grounded like this to the chassis. However, using an ohm meter, I determined that these actually don't go anywhere. I don't know why they're plated like that, but that was the first mistake I made. Therefore, this module has no DC sensing. It'll pull in, it'll pass signal, but if your amplifier blows up, it will not disconnect your speakers. And that is the main function of this. And that's why this was such a grievous error. I had incorrectly assumed that it was grounded through these, because you can see they're plated on both sides, but they don't go anywhere. And I determined that the second mistake and assumption I made, and you know what they say about assuming, is that the grounds here, the center terminals in each one of these, are not isolated. I thought they were isolated to each relay, but again, the ohm meter proved that they are actually common. And if you've followed the traces on the back of the circuit board, they're a little tough to see. You'll see they actually are. Initially, I had stuck my ohm meter probes in the screws here, but if that's screwed all the way down, you won't show continuity. When I tested from the back of the board and looked at it, I could see clearly that was a problem. And the problem with that is, if you use this on a floating amplifier and ground the two channels, you will blow it up. So those are two grievous mistakes I made, and I want to thank everyone for pointing these things out. The second thing is I got a message from Mark Zacharias. Now, Mark has been pretty good about finding my mistakes. He's found more than one. Mark doesn't have any new content on his channel, but the content he does have is excellent. He clearly knows his stuff. And what he pointed out to me is what I initially erroneously thought were the bias compensation diodes that clip onto the sides of the heatsink are actually thermal cutouts. Now, the schematic shows thermal cutouts here. However, it appears that there's two different either versions of this amplifier or schematics out there. I assume they just updated version 1, version 2. The schematics don't say anything, but one shows, I believe, is S602 and S603 for each channel, one for each channel. The schematic I was working off of did not show that. The schematic I had showed that there was a T1 as a thermal, looks like a thermal switch on the schematic, and I'll put that up there so you can see what I'm talking about. The other discrepancies between the schematics and probably versions is one of them shows a thermal switch that'll open the primary of the power transformer and kill all the power of the amp if it gets too hot. The second one that had the nomenclature for S602 and 603 did not show that on the schematic. But in any event, I want to show you what I had to do. It's very simple. I just had to run a ground wire. And I'll show you how it's easy to test, because the Adcom is a direct coupled lamp. It doesn't even have a a coupling capacitor going from the input into the base of the differential or long tail pair in the front end of the driver circuit. So you can just put a DC power supply in, you put voltage in, you'll see voltage come out of the output. So we're going to do that, and I'll show you what happens. It's very simple. All I had to do in order to get a ground in here is to simply run a wire from either one of these grounds on the terminal here, and I just ran it right to this bus bar. The easiest place to put it was right here. So I unscrewed this screw that joins the bus bars and one of the filter caps, and I put a ring terminal here and snugged it down real good. And I was able to test it with a DC power supply and found that everything is now working correctly. And I'll show you what happens when we disconnect this wire and why this was such a grievous error on my part. Okay, so right now I have the amplifier hooked up with a DC power supply going in the right channel input, and then the right channel speaker output is connected to my benchtop meter here. So I'm going to turn the amplifier on. You will hear it click out of protection. Okay, so it's out of protection now. You can see we have about 17 millivolts. It actually starts dropping off as the amplifier stabilizes. It's going up now, but I think it's settled down to below 10. There's no adjustment for DC offset in this amplifier. You would have to put in a match pair in the front end. But in any event, I'm going to turn this power supply on. And now as we slowly turn it up, you'll see that now we have voltage coming out of the speaker outputs. And you'll hear it click into protection. Now you still see voltage when we do, and it just clicked into protection. You're still seeing voltage there because this is a very high impedance meter. So if I just put 8 ohms across it, you'll see we have nothing now. All right. So we turn our voltage down. I'm going to leave the load on. Clicks out of protection. Turn the voltage back up. Clicks into protection. So it works properly with that ground wire, and we just heard it click out of protection. So now I'm going to take the ground wire out, and you'll see what the problem is. Okay, so it's very important that we run this ground wire in here. You can go into either one of these terminals. They are tied together. They're not isolated. So remember, if you have an amp that has balanced or floating outputs, you must use 2 of these modules, because if you use one and tie them together, you will damage your amplifier. And you have to put a ground in here for the DC sensing so it knows when it has DC on the outputs. We proved that. This was a grievous error I made, and whenever you mess up, you gotta fess up. So I wanted people to know that I made this error. I'm seriously thinking about deleting the original video and editing it, leaving the mistakes in, but putting a video like this at the beginning. Just so you know that everybody does make mistakes. I seem to make more than my share, and I thank people for pointing it out when I do. But anyway, that's all I have to say about that. I thank everyone for your comments. I do read them all. I try to reply to as many as possible. So anyway, I'm going to stop this video here. I thank everyone for watching, and as always, I like giving back to the community that's given me so much. Thanks a lot, folks.